Hello, welcome back. This class we shall see how a contrast image, how the contrast can be enhanced in an image. So let us first understand what is a contrast. The contrast means how well you can see the object from the background. That is, here the background and the image, they are almost same. You cannot easily able to distinguish the object from the background. Therefore, here we can say that it is a poor contrast image. Whereas here the background and the object, they are clearly visible. Therefore, this is a contrast enhanced image. Right. So, how well you can distinguish the object from the background, that depends on the contrast. The histogram gives an insight of the contrast. So a dark contrast image has a histogram cluttered towards the left, and a bright contrast image histogram is cluttered towards the right. A poor contrast image has the histogram cluttered at the center. What I mean is, see that this one is a poor contrast image, therefore its histogram is cluttered towards the center. If the image is dark, then its histograms will be cluttered towards the left. If the image is too bright, then its histogram will be clustered towards the right side, that is with the higher values 200 to 255. If the histogram is cluttered towards the left, that is between 0 to 50, it is a dark contrast. If it is cluttered towards the center, then it is a poor contrast. We can adjust the image. We can get a detail about the contrast by the histogram. MATLAB uses the function IMHist to identify the histogram. You see, here I have an example. Say that this image has very poor contrast, therefore its histogram is cluttered towards the center. This image is too bright, therefore this is also a bright contrast image, therefore its histogram is cluttered towards the higher end, towards the higher values, towards the right. And here this is a poor contrast image, therefore its histogram is cluttered towards the center. Likewise, if I have a dark image, then its histogram would have been, and a good contrast image, its histogram should have been spread out throughout from all the x values from 0 to 255. If the values are totally spread out, then the quality of the image would be clear instead of either centered cluttered or towards the left cluttered or towards the right cluttered. Right, we shall find this one. We shall see how this image could be contrast could be enhanced. Now let us take a simple image and we shall see. For example, if I take image is equal to IMRead, and let us take the image pout.diff. Right. So this is the image. Now let me show the image. Say figure, comma IM, show the image IM, and I give the title. This is the poor contrast image. Otherwise we shall say this one is the poor contrast image. Then we let us see another. Say that the image, we cannot able to distinguish between the object and the background. They are almost the same. If we analyze the histogram, you can see the IM hist of the image IM, and here we can give the title its histogram, and from the histogram itself, as I said, we can identify the type of the image. See that its histogram values, they are cluttered towards the center. A good histogram image, a good image will have its histogram totally spread out throughout the x-axis. So from the histogram itself, we can find that the quality of the image would have been very poor because all the values are cluttered towards the center. We don't have dark values, we don't have bright values, therefore we have very poor contrast image. How we can adjust this one? I can say this one is equal to IM, one is equal to IM histogram, IM adjust. We can say histogram equalization, HIST, histogram equalization, and now we can apply the histogram equalization for the image IM. Now let us show this image figure IM1, not this one. Let us show this one IM1, and let us say that this one is a enhanced contrast image, and let us see its histogram also. This one is equal to IM1, and this one is the enhanced image histogram. Now see that this one, let us see one by one. So this is the very poor contrast image, and let us see its histogram. This is a enhanced contrast image. See that the image looks very better. And here let us see, this is the histogram of the enhanced image, where the histogram is totally spread out. And let us see its histogram. Let us see the histogram of the actual image. So figure and this one, and see this one 4. Let us see this one 1, and this is the 2, and this one is the histogram 3, and this is histogram 4. From this itself you can very easily find out that a poor contrast image histogram is cluttered towards the center. A good enhanced contrast image, his histogram is totally spread out. Therefore we enhance the contrast by the command histogram equalization. So that is one technique of enhancing the histogram. The second technique is the gamma law. Therefore if gamma is equal to 1, there is no change in the histogram. If the value is smaller than 1, then the image will become brighter, and if the value is if the gamma value is less than 1, the image will become brighter, and if it is greater than 1, the image will become darker. This let us see. Say I have taken the second law. I have taken gamma is equal to 0.5. Therefore if gamma is 1, there is no change. If the value is less than 1, then the image becomes brighter, and if it is greater than 1, the image becomes darker. Therefore let us apply this one, control C, and now I will take a file, and if I copy this one, right, so I have taken 0.5, therefore it is less than 1, therefore the image will become brighter. Now then I convert the image to double, and I take the value of gamma. Since look, this one is a matrix, I use a dot exponent operator, and this is the value of gamma, and as I convert it to double, therefore I restore it to integer. Now let us see the actual image and its histogram, and if I run this one convert to double, therefore this one IM to double. What is wrong here? This one I have not taken the image, therefore I take IM is equal to IM read p out dot, and now if I run this, we will get two images. See that this is the poor contrast image. So we see that this is the image, this is the contrast enhanced by the gamma law, because we have made this histogram to appear this on the right hand side, the image becomes brighter. Now let us change. Instead of this 1, I will make this one equal to 1.5, and if we run this, then the histogram would have been cluttered towards the left. It is cluttered towards the left, therefore the image looks a little darker. If I make this value is equal to 1, then there will no change. You will get a centered cluttered histogram. Therefore this is the actual image. Here we can make the image, we can change the histogram either towards the left or towards the right by controlling the value of the gamma, thereby changing the brightness of the image either to the darker or brighter. So this is the second way of enhancing the contrast by gamma. Then the third one is very simple. We adjust the image using the image adjustment. See that I have taken image adjust. This is the image. I should have taken the image im equal to im read, and the image is p out dot take. Alright, we read the image, and I find this using the stretch limit what is the lower and higher value, and that I map to 0 and 1, and I show this image after the enhancement out 3 is shown, and the corresponding histogram is shown. So this is the image enhancement using the im adjust command. Now let us run this. See that here this one is the image which is enhanced by the im adjust command, and see that this is the histogram using after the image adjustment. From the histogram we find that the values are spread throughout. Let us see the actual image also. I take this one, Ctrl C, and let me copy this one, and here instead of out, let us say this one is equal to image, and this is also the actual image, and this one is the original image, and its original histogram. This is the original histogram. Now after that we apply the stretch limit and we enhance this one. So here now we can make comparison. This is the enhanced one, and this is the image of before the enhancement. Right, see this is the actual image, and the actual image histogram. So see that the values are cluttered, and after the image adjustment we use the stretch limit. See that there is how much quality difference is there, and from the histogram itself, without seeing the image, we can identify how the quality of the image will be. Since the values are totally spread out, the quality of the image would have been better one. So these are the three ways of adjusting the contrast. Either we can use the histogram equalization, or we can use gamma law, or we can use the image adjustment. Okay. Alright, with this we shall finish the contrast enhancement exercise. I hope this would have given little understanding of what contrast is and how it could be enhanced by various methods. Please do comment on the video, and please subscribe to this channel. We shall continue in the next lecture. Thank you so much.